Hi, everyone. The views, thoughts, and opinions expressed in the following podcast belong solely to the host and its contributors. They are not necessarily the views of our employers, organizations, committees, or other group or individual.
I'm David Campbell,
And I am Jordan Bullock.
And I'm Joseph Whitney. This is Brewing with BIM.
where we talk about construction processes, technology, BIM, and beer.
Well, hey everyone, welcome back to another episode of Brewing with BIM. As always, I'm Joe Whitney, and with me today is Jordan Bullock. Dave Campbell couldn't join us. What's going on, Jordan?
Hey, Joey. Pretty good. How are you?
Doing well, sir. Doing well. We've got a great episode today. Today joining us is David Robison. Dave, how's it going?
I'm doing great. Glad to be here. Thanks for having me.
Glad you could join us. So typically now is the part where we ask, "What are you drinking?" But it being noon, I'm not sure. Not sure if everybody has a libation in hand. So I'll just start off by telling you what I'm drinking, and it is some Nespresso coffee. So I'm super fancy today.
I've got my carbonated sugar water. It's in the form of Dr. Pepper this afternoon.
Some beautiful ice water over here. Yeah, nothing, no alcohol as of noon on a Tuesday. So
All right, so no secrets will be revealed. Alcohol-induced secrets will be revealed in this episode. I'm with you on the Dr. Pepper, though. I grew up in Texas, and I swear it is a staple. It's like it goes. You start off with baby formula, and you just advance straight to Dr. Pepper until you can drink beer, and then you just alternate.
Yeah, just don't put it in the baby bottle.
So, David, thanks for joining us. You are a part of a cool company that does something so much differently than what we're used to. Like we're talking with companies that are doing BIM, but you guys have a plugin that enables people to actually get their job done in BIM. Because we always talk about BIM in this context being the tool that we use is Revit, not mixing up BIM and Revit, but the tool that we're talking about is Revit to complete the BIM task. And it seems lacking, especially for the MEP side of things. Like you can't do all things, you can do some things. And then that's where companies like you come in and facilitate, the actual production side, the actual work side that needs to happen, but allowing us to do it in programs like AutoCAD and Revit. So before we dive into that stuff, though, I got to ask you, how did you get to where you are in this industry today? Like you and I have chatted about your background in the past. I find it to be very interesting with your dad and stuff. So tell the audience a little bit about yourself.
Yeah, so my dad runs or used to run, he just retired, an MEP firm out in Seattle, Washington. So I grew up around engineering. One of the early stories from my childhood is my mom set me down on a drafting table, and those were tilted. And so I slid off and fell off. I was like 2 years old. So that was kind of like one of my first stories about me. It's just, hanging out at architecture, at drafting tables and whatnot. And then I basically grew up in that environment, hanging around my dad's office. He was working in the early 80s in AutoCAD. And then in the mid 90s, obviously in AutoCAD still. And that was about the time where I started working with him, writing software to help automate the design that they were doing in AutoCAD. So it was kind of BIM before BIM even existed, because we're like, okay, we need to do a little bit more than just this drafting. So we started working on stuff internally for their own company. Then about 2001, we had the software to a point where we thought, well, maybe we could sell this to some other engineering firms, which in hindsight was horribly naive at the time, but we put it out there. And so we've been selling it for the past 20 years. It was MEP software first for AutoCAD. And then in about 2013, we put some stuff out on the electrical side for Revit. So we're very much focused on being a developer to allow the MEP engineers, and right now specifically the electrical engineers, to do their work in BIM.
That at the core of it is what we all need. You being from your dad rather being in the Pacific Northwest, I'm sure we've crossed paths at some time. I lived there for 6 or 7 years, mostly down in Portland, Oregon, but we had offices up in Kent, so I was up there quite a bit in the Seattle area. I had my first real takeoff in BIM, like my first real advancement in BIM, any like real great strides were in the Pacific Northwest, who seemed to be like anybody who could spell BIM was going to make a six figures, and it was a cool environment to kind of grow up in. And then as you get across the rest of the country and you start running into people who are just now getting to that level where they're starting to adopt BIM. And then they're asking, well, hey, how can we do this? It's so limited, or we haven't found a tool to do this for it. And that's where we're running into products like yours who actually help facilitate being able to do the BIM part, not just creating a model.
Yeah, because people want to be able to do BIM, but the engineers, they're busy doing their projects. They don't have time to write all this software. So that's where we're trying to come in and provide the tool for these engineers to actually participate in this process. And the electrical engineers do get forgotten a lot because they're a very small niche.
There's a running joke that the electrical side is the redheaded stepchild for Revit. It is. I've heard it used. I don't know, at least 2 or 3 dozen times from various electrical subcontractors and engineers. Revit just they weren't. It wasn't developed with them in mind. Rather, the mechanical. Mechanical and piping. Wet side and dry side. They seem to be the most vocal and had the easiest adoption with. At least for clash detection, but when it came to actually spooling and engineering side of things, it just it's still catching up, and it might be a while before Revit even addresses any of the electrical side.
The reason for that, I think, is that at its core, BIM is really a 3D model. And some people get offended when I say that. I actually offended an Autodesk guy once when I had that discussion back in the early 2000s. When I said, well, BIM's just 3D. He's like, no, it's not. And it really, at the core, is. You're talking about collision detection and the construction side, and that's all very 3D. So that's why things like the mechanical side get handled well, because you can see a duct, and that kind of has some dimensionality to it. So the people who are doing the Revit development, they kind of understand how ductwork works. But you get to the electrical side, and like the least possibly interesting thing for an electrical engineer is anything 3D. He doesn't care about the size of his panels or the size of their conduits. They're small. They're not really going to get in the way. There's so much other stuff electrically that matters, but it's not 3D. So it gets...
Yeah, conduit only matters for ordering and for prefabrication.
Yeah. As far
as like the actual, why an electrician is an electrician, the system stuff, like that's, the system analysis, that stuff's the huge part. But again, that's not stuff you see. It's all like underneath, and you have to have a complete, system to be able to test stuff. And there's so much that goes into it that often gets overlooked. And I'm with you on the BIM is the 3D, although I'll take a little bit of a little of a sidestep here and say that what I think is people think BIM is just 3D, and that, at least in the industry, and that is where we get hung up, is people say, companies, whoever, are doing 3D and calling it BIM, and that's where we're getting this misnomer. BIM is actually all about the information in the model, but we get, hung up on the dimensions are information, and therefore, the geometry is information. So therefore, we're doing BIM if we're just doing, basic 3D.
To kind of push that point on the electrical side, you could do electrical BIM without doing any 3D.
Oh, 100%. Yeah.
So that's where it's because really, when we think about BIM, there's always the 3D conversation, but there's this whole portion where you could do that's not 3D at all. So it's can you even do BIM without 3D? On the electrical side, you can.
Yeah, Jordan, I'll let you weigh in here since you have the more of the experience on the engineering side of things. But have you ever modeled a system, or at least inputted electrical information into a system without having had a model to attach, or an element to attach it to?
I was going to say, my experience, again, just to reiterate for anyone that is just kind of catching up within the episode. So David Robinson's the president of a company called Design Master, and their plugins are both for AutoCAD and Revit. And within those, I've actually used Design Master more for the Revit side on the electrical calcs. And, David, what he's saying is 100% correct. It's like everything you're doing within like a Revit software on the electrical side is almost identical replication within the Autodesk, where David's plugin is able to kind of come in and help out. It really ties in all that electrical information that would be within a BIM model, within really a 2D platform. And the ability within engineering to kind of do that, just like Dave was saying, Revit, it ties electrical systems together, but it doesn't really showcase all the little parts and pieces within the model like it does within, a plumbing system or a mechanical system. Just like we're kind of talking about, the ductwork, the piping, all of those have three-dimensional things. And within electrical, yes, you can run conduit or something, but a lot of the building electrical systems just, loads, calculations, running pieces and parts across the board. And most contractors will just be like, we can throw some wiring in the wall or something, run wiring systems kind of wherever. But really being able to fit that into a BIM model is not only important for coordination, but tying all that information together, starting off, at least where we're at right now within BIM and Revit, is really a lot more of the 2D side of things.
The way we describe it is we have our framework, we call it the electrical design triangle. And so clearly there's going to be three sides to it. You've got the construction documents, that's kind of all your 2D stuff, or it's really the Revit model. But then you've got, for electrical, this single line diagram, and that's just the connections between all those panels. And then you've got the calculations, where actually, sizing wires and doing fault and voltage drop calculations. And the first thing you do is that single line diagram, where you're saying I've got a panel and it's connected to a transformer, and maybe I've got, I know I'm going to have some mechanical equipment, so there's an air handler, but you don't even have a building yet. You don't have an electrical room to place any of that stuff, but the engineer is starting to think through all those things, and so they have to start building that. So we're trying to put together a model where you can start building that single line without even having a model yet for your building.
And it's already within your software. It already starts tying together the calculations and loads, does it not?
Yes. So and in terms of those three sides, the loads are handled by Revit. So that little portion is handled by Revit. But then the wire sizing and the voltage drop analysis, we do that in our software. And we have a system for actually doing that single line diagram, laying out those panels in a drafting view. And then we kind of put because Revit, they really want to know, like, is this panel matte or a glossy finish? And you're like, I don't know, it's just a panel. So you have to put in the 3D panels somewhere. So we kind of hide it in the background. We kind of lay them out as you're doing your single line, knowing that you're going to go back and place them in the 3D model later, but they have to be in there. So we let you put that single line diagram together and then kind of build in the background what's going on in Revit, but trying to let you do that without having to think about all that 3D modeling.
Yeah, that's interesting, because I didn't really think about that. Because whenever you're working in AutoCAD, at least from my experience, you're placing the data and attributes all at once, and then you're kind of being able to, like you're saying, reverse engineer that into your single line diagram, into your panel schedules, etc. But Revit requiring that panel information, at the beginning, if you want to start with the line diagram, seeing where everything's actually going to be wired, because you almost have to run your calcs first within an electrical schedule and paneling, and then actually placing that data, that panel within Revit, just because of the requirements. That's a complicated reverse engineering process within your software that not a lot of people probably think of as they're building these add-ins and attributes and things like that.
Yeah, that's where you need someone who's really focused on what the electrical engineers are doing, because what they're kind of, each discipline's in its own separate little world. And so you need someone who's very focused on the electrical engineers. And it's hard, Autodesk, multi-billion dollar company, to really focus on this very small niche in the construction industry. The electrical engineers are a very small portion of the fee. They're not really, they don't really get served just because they're so small. And so as a smaller company, we can be hyper focused on what they need.
Yeah, that's excellent. So you kind of gave a history of kind of working with your dad and coming up in the industry, and then started building tool sets for his specific company. What's your background? Is it in software development? Is it in engineering? Was this just kind of a passion project that you eventually started getting into, or how did that all come together?
So I grew up in the 90s playing computer games. I was like, what I want to do when I grow up? I want to write computer games. Turns out that's a pretty competitive space to get into. But I started writing software. So I actually did get a degree in computer science. So that's my background. It's like, I'm going to write some sort of software. and I was writing software for my dad's company. I was like, well, I could go write for somebody else, or I could take what I have and start selling this. So I grew up knowing that I wanted to do software development some sort of how, and I had this tool that I'd been developing. So we decided to take that out. So that's I don't have a background in engineering specifically, though I've done enough in engineering over the last 20 years that I understand all the calculations, because I'm doing a large portion of the development writing those calculations.
Yeah. So with your, going back to school and getting, learning code, programming, whatnot, I feel like maybe you probably have an interesting take on what's going on, nowadays with the new low code, no code environments. And, people are starting to find their, maybe they've got one small problem and they're just unable to do it themselves. Like, what's your thought and experiences working with, these various, APIs, whether Revit, AutoCAD, or whatnot, as well as, I'm not sure if you've experienced any Dynamo fumbles like we have. And then also, to take that a little bit further, we're like just scratching the surface now with ChatGPT's integration with Revit. Curious if you had any thoughts or input on any of that sort of stuff.
Well, thinking about like the low code and the no code, going back to AutoCAD when it was first coming out, one of the reasons it was so successful was because it had Lisp as that scripting language. And actually, our AutoCAD software is like 90% written in AutoLisp. So the low code and the no code is just kind of, I feel like it's a continuation of that. The Dynamo scripting is the same sort of thing. It's a way for people to get in there, and particularly like my customers, they're electrical engineers. They're all really sharp guys, and they've probably done some coding in college. They know what they're doing, so they can get in there and they can start scripting. So those tools are great for letting people do, the scripting that they need for their specific challenges, whatever their company is doing. It's hard to then take it and make that kind of a universal thing. But for something that you're just using on your own, those low code and the no code and all the scripting languages are great tools for that. It's really how we started. And, we see people doing it. And that's really how you can be, the most productive in Revit or AutoCAD. Regarding ChatGPT, again, I have a computer science background. And so I did a little bit of AI, but this was, 20 years ago. It's interesting. A lot of what they're doing is essentially what we learned 20 years ago. We just have larger data sets and better computers to run it on. So it's kind of, it's taking what we learned about. It's like, okay, this is kind of cool stuff, but we can't do that much with it because it takes too long. Now they're like, oh, we can actually do all these things that we thought maybe we could do 20 years ago. We've not figured out how to implement it into our software at all yet, so we haven't done anything there. But we're certainly using it for our own development purposes. It's a great, coding partner for figuring out how to do your development.
Yeah, I think our examples have been primarily like, hey, how do I write a Dynamo script to do this? Like, it's just so like my mindset is I will always find the easiest way to get something done. Call it lazy, call it what you want, but I wanted to automate things that I can, and ChatGPT kind of allows you to, do what you're already doing, but like, if you're using Dynamo, allows you to continue to use Dynamo, but allows you to just do it, more easily without actually having to type and write all the code yourself, copy and paste, maybe run it through a compiler, edit it, whatnot. But that's it. As far as the AI hasn't really changed thing, I'm kind of in the same boat. I think we've had the underpinnings, the algorithms obviously changed. The science has been, pretty much constant. It's just been the advancements in the technology all along the way, whether that's better algorithms and, things like quantum computing and all this stuff really allow us to analyze large data sets for whether it's predictive analytics, learning, whatnot. But that's how we get to the part that allows us to actually develop a real AI. ChatGPT, I think, in my mind, is quite interesting because it's learning from so many people at once, which is kind of cool.
Yeah, and don't feel bad about using it for your coding, because the professional developers are doing that too. I mean, now that we have it, I need to look up a Revit API. I'm working in C# and the .NET API, not in Dynamo, but exact same thing. Hey, I need to do this thing for my software. Okay, how's this API work? And then it'll point me in the right direction. I can then implement it in the software.
Yeah, my biggest issue with it is I'm still asking it Google type questions instead of treating it like it's smarter than me. Bard though is an interesting one. Apparently it's got a pretty robust coding engine behind it that allows you to it understands coding a lot better than ChatGPT is what people are telling me, which would make sense. It's Google, but yeah, not really sure how to use that one yet. No, sorry, man. I didn't want to dive off in a tangent. Just this is like the very interesting parts of what's going on today. I've had probably 2 or 3 people hit me up about Revit and ChatGPT just recently. So it's just always good to get a developer's mindset on the possibilities and what best use cases sort of thing.
I was going to say, as the API within Revit gets better at incorporating ChatGPT, I've seen it used in a couple video examples of just typing in, filter out all the doors in this project, count this, and using it for little pieces of information that you can technically do within the tool sets themselves. But being able to just kind of type in what you needed to do, it being able to code, or not necessarily code we're not there yet. Eventually, I'm sure we'll get to a point where we're like, hey, do this, and it's going to know Dynamo. It's going to know its own little coding platforms. Revit's an open platform, so it's going to quickly be able to just kind of compute and incorporate whatever it is you needed to do. If you want to run panels along the side of the building and have it, randomly generate panels in different directions or something like that, I'm sure eventually we're going to get to a point where you type something in, it generates a Dynamo script for that. It's able to do it all itself within a few minutes, and really taking that to the next level. I mean, Joey, we're only a few months here out before I just kind of strap on one of those VR headsets and have a Revit model and just type to text to all my ChatGPT information. It's building Revit models in front of my eyes. Super excited about the technology that's coming out. And do you have any thoughts, Dave or Joey, on kind of that side of things as far as like getting into VR, using ChatGPT technology, really anything with the open source platform and kind of where we're heading?
Well, on the electrical side, again, VR is not going to be the interesting thing. But where I see the AI being valuable is eventually having it do a lot of the kind of rote layout of stuff. Like, hey, I need light fixtures. Okay, right now you have to have a designer go through and place all your light fixtures in all your rooms, and then you got to circuit them up. You could probably have an AI doing that and say, hey, throw in light fixtures. I want 2x4s everywhere, and then circuit them to some panels and make sure you don't overload any of the circuits. And that would be where AI could actually just go out and do that layout for you, and then you can go back and check and make sure that it's something reasonable.
Yeah, tie in your photometrics, for lighting and whatnot, and your requirements for that space, and it pulls up all the various pieces that meet that those specs for your lumens or whatnot. Foot candle level, whatever it is. I'm very green when it comes to the lighting side. So
those are all the right words.
Okay. Yeah, I mean, imagine throwing that in there, having it specify. It pulls up a list of all the things that meet that design criteria.
Yeah, and even something like the single line diagram, where right now you kind of have to draft that out yourself. We've got some stuff to generate it for you, but if you could say, okay, here's my layout. I'm going to kind of build a tree. You go draft this for me. You put it on the drawing for me and lay these things out. But that's starting to, again, getting into more like the image manipulation portion, not just text stuff. But there's definitely, I see potential there for the AI being valuable.
I was going to say, you and I and David talked about this a couple episodes ago, but we were talking about, eventually a ChatGPT, open software for specifically the engineering industry where we're able to, it's analyzing code books along with like existing subsystems and, being able to incorporate something like that into an add-in within Revit where we go, hey, here's the codes we're following. These are the system requirements. I know just from, an engineering standpoint, one of the things we run into a lot of times is, hey, we have an existing building, we have an existing system, and we're trying to maximize the use of the existing system on the new system. What's the best way to change that? What's the best way about going about doing that? And it's, just like David kind of mentioned here, was it being able to kind of calculate and run through and figure figure out exactly what it's the best way to maximize that and the most efficient way to maximize that. Or I think we talked about in that episode too, like finding new ways to engineer. So we have all these ideas of like, here's what we typically do when we're engineering things. We're only a few steps away from it accidentally engineering a completely new product or a new system that's maximizing things that we're not even thinking of right now. Super exciting time.
Yeah, the crazy thing is all that data is already available. I mean, it's just being able to comb through it in a meaningful amount of time, right? If it's 3 weeks, to save us very minimal stuff, it's not worth it. It's not cost effective. Or maybe 3 months, probably a better example. But if it does it in minutes, like an AI platform could do using elastic computing or quantum computing or what have you, it allows us to make it very cost effective and time effective, essentially. Sorry, man. I feel like we forced you into an AI conversation just because it's again, it's something that
every conversation right now turns into an AI conversation eventually.
I'm going through and I'm looking at different functionality of your software, your plugin. A lot of this is very foreign to me, but what specifically is, so I'm looking at like feeder sizing, arc flash, voltage reps. What specifically was like the wow moment for you guys where you're just like, okay, this feature right here, this is everything everybody wants, and this is what makes us a company?
What we found on the Revit side is the single line diagram that I keep talking about, because Revit doesn't have any conception of that. So right now, the current workflow is that you lay out all your panels in Revit, you give them names in Revit, and then you go and you do this totally separate drawing that's your single line diagram. And you got to have all the names the same, and you got to have all the connections the same. And you've got two completely different models. So the idea of this single building model, it's like, well, we got this 2 building model. And so any change you make in one, you have to go back and make in the other. And the single line diagram is really how the engineer's thinking about it. And then obviously the Revit model is important, but that's not where they're thinking. So they've got these 2 models that they're constantly having to maintain and keep synchronized. And so either it's this huge synchronization challenge, or it's change orders when you make a mistake and you don't actually get it updated in one or the other. So the single line diagram is really what people are looking for. And then we add these other things on top. And like, oh, I didn't even know I wanted that because that was just so far removed from what Revit could even potentially offer us. So the idea, like you mentioned, some of the things there, like doing an arc flash calculation, no one's even thinking about doing that in Revit because there are so many steps to even get there from where Revit is just out of the box. And arc flash, if you're curious what that is, that's a calculation where when you're working on the building live and it's powered up, if something goes wrong and essentially you get an arc, which is a current going between 2 parts, and eventually it's an explosion. How much safety gear do you need to be wearing so that you survive with 2nd-degree burns after that? Is essentially what that's calculating. And they put a sticker on there telling you what to do. So it's some huge important life safety stuff in terms of just like keeping the actual contractors out there working in the field safe.
I feel like that needs like a warning label, like when we're talking about arc flash right there, like that needs some serious attention. I had not put a lot of thought. Again, man, I'm a Luddite when it comes to the electrical side. So I apologize. If it's not, big, sexy geometry that I can manipulate, it's hard for me to conceptualize. But being the electrical side, like I grasp electrical single line diagrams and one, was a riser diagram because of AutoCAD electrical, way back in the day, which it's still around, but it's like just part of the AutoCAD tool set, I think. Like nobody.
AutoCAD electrical exists, but it's really for different stuff. It's not for building design.
Correct. Yeah.
It's for controls and other stuff.
Yeah, but that's where I ran into like single line. That's pretty much it. Yeah. On the Revit side, though, so your tool allows users to create the single line. Is that creating the single line from the model, or does it have any interaction with the model?
Yeah, so the single line we create, it is a drafting view, but it is linked to the model. So you make a change in your model, you give it a new panel name, you resize a wire, and that updates in that single line and our Revit model. So we link them using the magic of our software so that it essentially becomes that single model that you want. even though in Revit doesn't know that, but our software does.
Yeah, I was just going to jump in here. That's probably one of the biggest advantages because that's an area that Revit doesn't really touch. So Revit over AutoCAD, I would say, does a little bit better of a job of tying in pieces of information. So when you're working in different views, you're working with different pieces of information within your actual system, tying in schedules to actual Revit elements and parameters. And we all know how Revit works at this point. But being able to tie in those pieces of information all together, the one area that kind of lacks for a lot of engineers, architects, really anyone across the AEC industry is being able to tie information that you're inputting within your family softwares. Actually, I think architecture has this a little bit more developed than MEP, but engineers don't really have the ability to, as they're going through and creating specific elements, modeling specific elements, especially as David was mentioning on the electrical side, because electrical doesn't really have a lot of 3D stuff going on within Revit. It's hard to create those details and diagrams of what you're actually showing within your Revit model of specific situations. So if you have a 3D element, and this is where, architecture is so well developed within Revit, you can do a wall section, you can detail certain pieces. But on the engineering side, some of that stuff is kind of factored in, or some of that stuff is, showcased like a line diagram or another diagram. It's showcased in representation of those details of how the actual calculations are being conducted, how everything's actually tying together. And there's not really truly a good way to show that through 3D objects and 3D items. So David's software on the Design Master side, that the ability to tie in drafting views or line diagrams or information to the actual information that's in your model kind of takes that into a step further. It really helps, the MEP guys as they're kind of going out and trying to tie some of this stuff together. We talked a lot about the electrical just because that's probably the one that has the least amount of modeling, but what kind of stuff do you guys do on the, HVAC or plumbing side that kind of aids the MEP group as a whole?
So we don't actually do a whole lot on the mechanical side at this point. We have our AutoCAD-based HVAC software. We had a plumbing software that never really took off. The workflow never quite worked out. But we have our ductwork software in AutoCAD. And it can do full 3D modeling, 3D. It's essentially a BIM package that's running in AutoCAD. And it works really well. But the market is not as much there in terms of interest because on the Revit side, again, ductwork is 3D. Architects and the developers can kind of understand that. So Revit does well enough on the mechanical side that we don't really have any value to be added there. So we actually have not done anything in Revit on the mechanical side. And that's kind of on purpose because there's really not as much value to be added. It's the electrical where there's huge gaps in what's there. And then the mechanical, it's actually pretty good in terms of what Revit can do. So we're not trying to address any Revit problems on the mechanical side right now. And just as an example of something that is, doesn't work well in terms of Revit on the electrical side, you have your conduits, which is like one of your major pieces for your electrical design. Those conduits are not at all connected to the actual wires that they're being run between panels. So you have panels, they have connections. Revit can kind of do that. They're a logical connection. But then you draw in the physical conduits, and there's actually no link between that logical connection and then the physical conduits in the model. So even the one 3D part that the electricals could potentially care about is done in a way that's not really all that helpful. So you change a conduit size, and it doesn't know that those things are even the same thing. So we're working. We've actually got an integration with another developer called Evolve. They're on the contracting side. They do the prefab of all those conduits. So we're going to take using your other term, bridging the gap. We're going to bridge the gap between the design and the construction, where you can take the conduit sizes from your design side and push them over to construction, because that's what you do need for that 3D modeling and the prefab. And Revit doesn't address that at all.
I think we're well aware now at this point that the electrical side's kind of been left hanging. We're familiar with the Evolve side as well. So the engineering has always, obviously been like I said earlier, the redhead stepchild. Subcontractors just as well. Like again, outside of the visualization, so prefab side of things, it tends to be harder. We have to create assemblies for everything, even if we want to get the spooling plugins to work. They were just not as thought about as much. So all these tools that are starting to come to the rise to the top for the electrical side just to get the job done, like your plugin as well, like makes life so much easier. And when people are mandating Revit on a job, or BIM in particular, LOD 500, well, what does that actually mean for us? We're an electrician. You guys can actually put some data behind it.
Yeah, the fun thing about like those LODs and anything is that it'll be like super specific on what you need on the architectural side. And then you get to like the electrical section of those, and it's just this very paper thin document, because they're like, we got to the electrical and we kind of got tired and we don't know what we want. So probably maybe some conduits, I guess. And that's all they do.
Can you make sure there's outlets in the building? Yeah, do that.
Yeah, like we want some power somewhere.
My favorite thing though is like when talking with owners specifically who are saying, yeah, we need some of that BIM stuff. And then you start diving through the rabbit hole of LOD, and then specifically having them outline what they want LOD, and why they want it, doing the justifications. And most of the things, the elements that they want to have high LOD are not elements that as an owner you should actually care about. It's more about for marketing purposes and showing renderings and all that sort of stuff, and and making it look good, and having it for because they can. But really, when you get into the system side of things, the MEP, the assets that actually make sure the building is not going to catch on fire, and warranty and service dates and all that sort of stuff, that almost becomes an afterthought of putting that information inside of your model. So the electrical side, it doesn't surprise me that they're very paper thin on that sort of stuff.
Yeah, we try and implement any of that through our software. It's just like there's nothing to implement. There's just nothing there. And there could be some stuff in terms of like the building life cycle. We were talking about the arc flash. That's stuff that they have to maintain, and that's very much based upon the actual configuration of the specific breakers you have in, and things like that. And then they do have to go back and recertify that. And that's a place where if you actually have a good BIM electrical model that's maybe not, again, 3D, but has all this information about which breakers are in there, what actual panels do I have, that when you go back and redo those arc flash calculations, if you make a change to anything, you often have to redo those, where having an actual model of your building on the electrical side is going to be helpful. Because right now, anytime you do that, you have to go back and essentially do the as-builts on the electrical. So that's a place where facilities management can get value from on the electrical side, in terms of maintaining those safety warnings.
Yeah, that's a great idea. Obviously, we're always pushing for models, 3D models, for life cycle management, for a project. The overall cost of a building extends way beyond the actual initial building. It's the life of the building itself is where the majority of the cost goes, and people don't realize that. But with that, though, like, where does that data live? Do you just leave it in your model and hope that 20 years from now, when people are going back to it, that Revit's still a thing? Is it in your Maximo system? Like, I guess that's probably the part that needs to be addressed from an owner's perspective, is what is your life cycle management tool for this building? Is it your IWWS or whatever? Is it your asset management system? Is it your FM system? Is it this BIM model? I guess I don't know, man. I don't know the perfect answer. I'm just throwing it out to the ether.
Yeah, it is a problem, because you got to have something. Okay, what's going to last the length of this building? I need software that's going to be here in 20 years. I feel like Revit might have the chance to do that. Looking back at the history, again, starting in the mid 90s, you had Sofdesk, which Autodesk bought out, and then they made AutoCAD architecture, and then they replaced that with Revit. There was all of this flux in the mid 90s and the early 2000s. It settled down. They appear to have kind of, stuck with Revit. And if we could keep Revit moving forward, it's something that in 20 years, maybe you would be able to go back and look at your model still. You'll just take a little while to actually open up that model in the current version of Revit while you wait for it to update.
Yeah, I'm with you. I believe Revit's going to be around for a while, and AutoCAD in its current state or even a future state is still going to be around in some form regardless, just because a lot of people don't realize this. AutoCAD is still the most sold Autodesk application. Bar none, it is still the most used, most sold piece of software that Autodesk has in its arsenal. Revit has gained a lot of mainstream attraction over the past, 10, 15 years, maybe 20, 25 years, more in the last 10 years, I imagine, for commercial and industrial healthcare, type projects. Have yet to be consistent in breaking the barrier for residential, starting to see, a lot of multifamily mixed use adopt it. But it's starting to trend there, right? And I think in order for Autodesk to come in or somebody else to come in and flip it on its head and introduce new software, it's got to be revolutionary in a lot of things. It has to. What Autodesk did with Revit was, or Revit technologies. What they did was very smart. They focused on the architectural side, the document management or the document creation side of it, right? Yes, there's design data becoming it, but the documents, they actually get created as you're modeling. So it makes sense. It was a pretty smart, tool, and seeing it progress over these past, multiple decades, and branch into the other trades and industries that are associated with the AEC, become revolutionary. It's as Revit gets smarter with the tools and the way that people interact with it, the more use cases that we'll get out of it. That said, I do foresee like some of the legacy products like Civil 3D or something like that. Like I pray to God that they get replaced with something more intuitive with a cleaner UI like Revit.
Yeah, I don't want to see Revit replaced, because if it was replaced, it would be replaced with something starting on the architectural side, and then be another 20 years before you get to the single line diagrams and on the electrical side again. The fact that Revit's been stable-ish for 20 years means that we can finally have these tools for these smaller niches actually being built, and actually have time to get their development. Because again, we've been doing our stuff for 10 years. And so it's taken 10 years to get to a point where we have some stuff that's really starting to be pretty powerful on the electrical side. Developing software can take time.
Yes. Developing the software and then getting the adoption, the traction. I think we're in a healthy start right now. Again, knock on wood, but where we're seeing with Revit is that not only does it have enough adoption, but it has enough companies like yourself filling the niches, the voids where software gets us 80% of the way, and it has someone else has to come in and get us the rest of the 20% for our specific tasks. I think we've got the right marketplace now where these apps have been created to facilitate those gaps and voids. So I feel like, we're and again, knock on wood, we're in a pretty safe place for Revit as far as adoption. I think we've covered every topic in the world at this point.
Yeah, I was going to say we can go anywhere, but alcohol makes the conversation flow a little bit easier sometimes, but I was just going to say,
we get drunk and share secrets. That's probably the key there.
David Robison, thank you so much for joining us today in showcasing your company, Design Master. If you want to do a quick shout out, kind of let people know where to find you, where to find your company, and anything else you may want to add here at the end.
Yeah, it's been my pleasure. I've really enjoyed this. Our website is designmaster.biz. You can learn more about our software there. We run a webinar every month talking about how to create your single line diagrams in Revit. Obviously, we talk about our software, but we talk about the other best practices as well. So for any electrical engineers, if you do want to see kind of our design philosophies and what we've learned from talking with other engineers, we have that webinar available, and that's on designmaster.biz.
Awesome. Thank you very much, David.
For those of you that are listening, we'll throw a link to the website in our description.
Thank you, David. It was great having you. Good luck with everything, and hopefully we can have you back on and have some alcohol that time. It won't be a Tuesday at noon that we're meeting up here. And once again, thank you for joining us. Like and subscribe and follow along if you haven't already. And thank you all. Have a great rest of your day.